Our final project will be the tool post from Technical Drawing with Engineering Graphics, 15th edition. Because of the curriculum for the coursework, I really need something that ties all these concepts together. We've drawn a bunch of parts. There are plenty of strategies that lean towards the CSWA, but for our application side, we really need to be able to take all of these concepts and tie them together. So a couple of things that we'll run into, we haven't gone too deep into the threads and the threading. Of note is the half 12 is not a standard size. The 3B is not a very standard hex nut. That's probably going to be a little bit more expensive if we can even find one, and therefore the half-inch 12 2A, which seems a little loose for to have a 3B on the nut. We'll talk more about the classes of fit. So 5/16 18 and the 7/16 14. We'll discuss those a little bit more. Other than that, the goal is to see through all the noise. This is a very busy drawing. One of the reasons that I like the technical drawing is it's putting everything in one place, and you kind of have to look for some things and visualize what's going on with this assembly. So if you've taken a tech drawing class, a beginning drafting class that has used the technical drawing book, um, hold on to them because I think they're a valuable resource. We've talked a little bit in class about the standards. The ASME standards are scattered throughout. They may not be specifically called out, but they're there. And the recommendations, the views, all of the things that we're incorporating come back to those standards, to those recommendations. So let's see, what else can we do on this? The knurl will be an optional. It's not going to be required. There are different ways to approach that that'll be addressed in optional. There'll be several things that are optional videos to work with this. And the different threads, we're going to do cosmetic threads, and we'll come back around to the thread wizard and to the other strategies for managing those threads. So let's go ahead and get started with making a project folder. So we'll get our parts going, part inch. These are all in inch this time after the semester of doing all of the metric, or mostly metric. The real quick mention, the chapters 7 and 8 and 10 we'll circle back around and pick those up as again optional preparation for the CSWA. Let's see, let's fly this back in. All right, so I'm going to start with the body, and somewhere there is a description. All right, so the tool post body, it's saying it's cast iron. So since these were, oh geez, in existence in probably since the third or fourth edition, um, casting was fairly common for a lot of these projects. If I was going to update these today for current manufacturing processes, there are things that I would and wouldn't do in this setup. So the tool post body will stay with that naming. May even put the item 1 on it. Not really necessary, but we'll go with their naming scheme. And when I look at this, the thing that jumps out is that if I go with this in geometry, I could probably get most of this, maybe even the rectangle, and put in the angle after. So my first sketch will be on the right plane, and I'll probably go ahead and extrude this mid plane with the origin at the bottom center. So going into the right plane, I don't know that I'm really interested in creating a center line that it's going to be functional, but we don't get to use the midpoint line that much, or at least I don't. So if I bring that one over, hit escape, go back into the line, midpoint is not there. And we can go up, over, down, back around. Still not really that interested in trying to hold on to those dimensions. We're just getting something close. And if you need to sketch portions of this, because somewhere in here I'm pretty sure I'm going to have a good example of an inferred relation. All right, so some things that I can do right off the bat is we'll go collinear and equal. And I'll use the zoom to kind of move out a little ways. All right, so let's start at the bottom. And we have a dimension of 6.56. All right, so if that's a number, it's a fractional. So 032 deep, 094 wide. Oh, and that would probably help if we hadn't scaled that to 6 inches. All right, so 0.656. Let's see, what do we have for a depth? 188. And since that jumped to the upper, let's go ahead and select the bottom. All right, so we know the fractional dimensions, 188, I recognize as 3/16, and the actual numbers, if we look at a chart, are 0.1875, the 3/32, so 94 is rounded up from 0.039, or no, that's the metric, 0.9375. And the 032 is a 1/32. So if we wanted to take those out to more decimal places, the main thing is that when you're dealing with the inch, is that you are being consistent in holding the decimal places to 3 decimal places. So that was an interesting overlap. Let's see what we can do there. All right, so that initial scale where I put in the 6 inches is coming back to haunt me a little bit, but let's see, that was to center line. We have an overall of 4.563, so 4 9/16, and that is from the very bottom. And we're just going to go through process of elimination that we can get all of these in place. And the downside to drawing this complete is that when it's scaled, it is going to do some strange things until I get it all sorted out. So let's go ahead and keep moving these around. Nope, that can't be horizontal, so Control Z, switch it to, oh, no, they already are vertical. I need collinear. All right, so just a quick review is that when we go line in line, those are going to be collinear. If we go to a point in a line, that will be coincident. And if we go point and point, those will be vertical. So I lean towards going to collinear because I like those large targets. And everything that flip-flops on me, we will bring that back in. But I like the large targets and makes the selection process easier. All right, so 0.5. All right, so this is starting to come together. We have 0.875 from the top. This is also a really good example of we designed for convenience. Notice that we're following their geometry, but realistically, we're going to put these numbers in, and then we put this in the drawing. We're going to detail it for manufacturing. All right, so I said I was going to try to cut away the angle. I'm probably just going to have to add the angle back in. So since the number is kind of in the lower left, we'll just fill this back in with that 20-degree angle. All right, I think I've got enough geometry. We'll go ahead and extrude to the midplane. And we have an overall for that distance of well, let's bring it in, see if I can find it. 1.625 on the through. 1.25, which means there should be a 2.5 hiding in the shaded area. All right, so 2.5 and enter. All right, so shouldn't really matter if we go from the front of the sketch. I'm going to use the rectangle. You can certainly draw for actually the 3, because that's going to come to a point. So that being the case, you could draw the 3 lines, but I like to make things complicated, so I will draw the rectangle, delete a line, delete a relation, and then generate my my geometry. All right, so we're not going to be up to midplane on that one. We're going to be up to next. And we need to reverse the direction so that it can find it. And yes, we want a merge result. So pretty quickly, we have generated the majority of the geometry. The top will be through holes. We're going to need to come to some agreement as to how we're going to manage the tolerance. So this is a limit dimension at 502 to 504 through. Maximum material condition for a hole is the smaller size. There's more material because it's a smaller, and then 504 is removing more material. So when I look at that number, I instantly think maximum material is going to be the 502. The through hole for the pin then is 5/16 with a counterbore of 375 by a 1/4 inch deep. So nothing too crazy there. We'll probably just generate that in two features rather than trying to override the whole wizard. I don't think that is going to be as efficient. So we'll open up a sketch, and we're going to put the through hole, and it is going to be 0.502. We need a dimension at the 1.25. And did it infer? No, it just happened. So I don't see a bunch of decimals over here, so that makes me feel a little bit better about it. The number for the in-between then, assuming that it's on center, we could check real quick. I mean, realistically, it should be at the origin, but I don't see that that dimension in the view. So we're going to go with the origin, and I put that dimension in there, so this would be a good place to make it driven. Driven just means that it's free to move, but it will return that value as a reference. So I know I applied it. There is something going on there. If I come back to it, I can see what I did. All right, so the extrude cut will be through all or up to next. Since we're on the top, let's go into the whole wizard. And I'm going to hold off on the S key. My natural tendency was to go to the S key. So previously I had overridden some dimensions here, so let's reset make sure that we are now in ANSI inch. And we are looking for the threaded holes to be 7/16 14. So let's find our size. And I would say from a machining standpoint, I don't run into 7/16 14 that often. They do show up, but chances are we're going 3/8 is going to be something we use more often. I don't know that there's a strength issue here for holding down whatever tool post or adjuster that they're doing. So we do want to go up to next, because the through wall would find its way through the bottom of the part. And then its position, let's put one there, and we'll go to the select. I'll make sure with the select control select that I am horizontal. And we have, I need to just do smart dimension. We have the dimension of 1.625. Now here's where we're going to run into kind of our first problem. If this was aligning to the geometry, then 0.813 is going to give us a half a thousandth variation. 0.8125 is the actual. So if I really wanted this centered, I could put in the other decimal places, or I could create the center line and make these symmetrical, and it would automatically calculate. So, just things to be aware of in the inch system that don't really come up as often in the metric. All right, so where is that one? We need to find its vertical. So the inside edge is 0.48. Well, it looks like they managed to get one in, so the 0.375, yeah, that one's kind of scribbled in, hard to see, but we'll go with it. All right, so there again, if I knew I wanted it to be centered on this inside edge, I could go to my hidden lines visible, my wireframe. But let's go ahead and see what we get with the smart dimensions. So we're going to go 0.485 plus 0.375 and see where that lands it. All right, so 8.6 on the hole position, and the cosmetic thread is put in automatically. So when we expand this out and we are looking at the sketches, again, we'll see the point location, we'll see the profile, and then hole thread 1 and hole thread 2 are the cosmetic threads that were generated. All right, so working around the back, let's go into the hole wizard again, and we're going to be doing the threaded holes. So this is a 1/4 20. Notice I'm not doing anything with the class of fits just yet. I do want to analyze those a little bit more initially. We're going to go through and make sure all of the geometry gets in, then we'll decide what is needed. All right, so our 2 hole locations, we'll make those horizontal. And we have the 1.625 again. And if we go to the origin and pick one, 0.813, yeah, pretty much going to have to do the 813 for those two split again. So looks like they gave a point, the 0.437. I'll expand that out a little bit. The 0.437, so 7/16. And so if we wanted to see where those numbers fall out, So we get the 0.437, and we'll call that close enough. So it is on the rounding, again, going to the four place decimals. Oops, got out of that a little too soon. So I can either right click and edit the sketch, or can right click and edit the feature to get back into the positions. All right, so we needed that to be 2.65, and that one is off of the ledge, not the bottom of the part. So 2.625, and now we can accept it. All right, so if we edited the sketch, that would be doing the same type of thing. All right, the 5/16 through. And that, let's see, the way they're kind of going is it's off of the ledge, so we're going to put in the 1.219, which is what 730 seconds, 21875, and we said that we were going to go 5/16, so 0.312. Notice the habit of putting in the fourth decimal place, and we're going to have a distance from the front of 0.375. All right, and then we can extrude, and it will go through all, so that's fine. Open up our next sketch. And put in the diameter, 0.375, and extrude cut to a distance of 0.375. Okay, so except for all of the fillets, we have generated our geometry. So this would be a good time to save. And we're going to go back up a couple levels. And I will call this my, actually we need to do tool post body. And then I'll create a new folder, and this is going to be my final. Okay, so very quickly we can create and start to organize our files. Okay, so the radius is 0.063, basically all the way around. I don't see that I've made any really crazy misses, so let's go ahead and start picking some fillets. I can go through and select on a couple and then see if it will pick the rest for me. And we're kind of fighting that internal external. So from a casting, the fillet's going to be fine. From a machining standpoint, if I was making one of these out of aluminum or a block of steel, I would really want to consider the horizontal fillets because they take more to set up. The roundover tools, I might consider just putting a heavy edge brake as a chamfer or something else on those to make them work. All right, so we get our geometry in. We've gone piece by piece. I think we've made good decisions. We know where the hole locations are, where our cosmetic threads are, and we've decided that we're going to stay with the 3 place decimals. So that gives us a good start.